So this is section 2.2. We're talking about polynomials and rational functions. Whoops, I forgot I'm not on Notability. All right, a polynomial is a function of a degree of 2 or higher that when you graph it, the graph is smooth and it's continuous. There's only rounded curves, there's no sharp corners, there's no breaks. God bless you. You can draw your entire graph without lifting your pencil. So when I look at these graphs here, the ones on the left are graphs of polynomials. Do you guys see how they are continuous? There's no stopping and starting points. They just go from the left-hand side to the right-hand side. And it's nice and smooth curves. We have bumps in the road and that sort of thing. Those are called turning points. But there's nothing that's a sharp, jagged corner. And it's not broken up. Do you guys see down here how these have stopping and starting pieces? This right here is a sharp, like they say, edge or corner or something like that. Our polynomial graphs are going to be nice and pretty and smooth. Okay. When we talk about sketching graphs, we are going to talk about things that are x to the 5th, x to the 7th. You guys aren't familiar with those. But in your mind, you need to get a picture. And what I need you to get in your mind is that if the highest exponent, all right, you always have to look at the highest exponent. If the highest exponent is even, it's going to resemble that of an x squared graph, meaning, what are both of the arrows doing in the graph of x squared? Same direction or opposite directions? Same direction. Okay, so if you have x to the 4th, and I'll show you this in a second, you're going to have a graph that both arrows are going in the same direction. If it's positive, which way are they both going? Up. If it's negative, which way are they both going? Down. Okay? Because we're going to be talking about end behaviors. If the highest exponent is an odd number, it's going to resemble that of a cubic function. Think about a cubic function or a line. They look something like this, right? Yes? Odd means the arrows are going in opposite direction. If it's positive, it's going to look like that. If it's negative, it's going to go this way. Think about a line. If a line is positive, it goes up. If a line is negative, it goes down. So think of it that way. And then the greater the value of n, the flatter the graph is near the origin. So if I ask you to, just in your mind, think about this. First of all, if I look at A, it says x to the 7th plus 1. What does that plus 1 mean? It moves up 1. Good. If it's x to the 7th, think about what the ends of the graph look like. Are they both going in the same direction or are they going in opposite directions?
Opposite.
How come?
Odd.
Because 7 is odd. Good. Is it positive or negative?
Positive.
Positive. So it's going to go something. You got an arrow up here and over here. Something like that. Whatever. But just understand what the direction looks like. That's super important. In B, what does that minus 1 inside the parenthesis mean? Right one, good. And it's to the 4th power. So that means both ends are going to be going which way? The same? Which way? Up, because it's even, positive. So it might look something like that, whatever. We'll talk more about the graph, but you guys really need to get in your mind what the highest exponent, what the highest degree is telling you about your graph. We're going to be talking about the leading coefficient tests and stuff like that. So this is what the book tells you about end behaviors. We're going to talk about things falling and rising. If it's falling, which way is it going? Up or down? Down. If it's rising, which way is it going? Up. Okay. This is, I think, an easier explanation. If you have an odd degree, so circle the word odd. Odd goes with opposite. That means our ends are going in opposite directions. Okay. If it's positive, think about a cubic graph or even a line. If it's positive, on the right-hand side of the graph, which way is that arrow going? Up or down? Up. On the left-hand side of the graph, which way is it going? Down. So if you had a positive odd function, you would tell me that it rises right and does what on the left? Falls left. If it's negative, think about a negative line. It goes this way. What's happening on the left-hand side? What's happening on the right-hand side? It's falling on the right. What's it doing on the left? Rising. It's pointing upwards, right? That's what we're going to need to remember. If I have an even degree, they have the same. So this is a little easier for us to think of. If it's positive and it's even, both arrows are going which way? Up. They're both rising. If it's negative, which way is a negative parabola point? Down. So then the end behaviors both would be what? Is that rising or falling? Falling. You guys are going to have 2 words. Rising means up. Falling means down. So if we look at this. If I give you something like this and I say, use the leading coefficient test to tell me the end behaviors. You can do you can answer this question without doing anything but looking. First of all, I'm talking about end behavior. That's what the graph is doing at the ends. Are the arrows going in the same direction or are they going in opposite directions? How do you know it's opposite? Because that's an odd number. So that means opposite. Odd means opposite. Okay? Is this a positive graph or a negative one? Negative one. So think about this. A negative line or a negative snake, a negative cubic, it goes like this. Right? You guys agree with me? That's how a negative line would slope. Well, look at the ends of the graph. On the left-hand side, is it rising or is it falling? So you would say it rises, left, and then what's it doing on the other side? So you would say falls, right. If you wrote falls right, rises left, doesn't matter. But just make sure you have the rising and falling in the correct direction. We like that question a lot better when it's an even number. It's real easy. It's either both rising or both falling. All right, here's our factoring. In a polynomial function, the values for which x equals 0 are called the zeros. You will be asked from now until the end of this class and beyond. They're going to ask you sometimes, what are the zeros of this function? That means the roots. That also means solutions. That means x-intercepts. Where does this graph cross the x-axis? That's what all of those things mean. So if I ask you what are the zeros, that just means where does it cross the x-axis. If I ask you what are the roots, that's where does it cross the x-axis. If I ask you what the solutions are, what does that mean? Where it crosses the x-axis. How we figure that out algebraically is our favorite thing in the world to do, which is what? Factoring. We have to remember to always look for what first? GCF. Right? Then we have to look for some special patterns, like maybe the difference of perfect squares, stuff like that. If we have 3 terms, that could be that's a trinomial. If we have 4 terms, what do we do when we have 4 terms? You group. We're going to do all this kind of stuff, guys. It's all basic algebra 2 stuff. Factoring, 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 factoring. Everybody's quiz version will have one of these where it's going to ask you, tell me the end behaviors, tell me the multiplicity, tell me the zeros, that sort of thing. As soon as I explain multiplicity, you're going to be like, oh, that's easy. I got that. I have multiplicity in my life. Why do I have multiplicity? I have 2 that I had when?
Oh, at the same time.
At the same time. I have twins. Multiplicity, just think of that. If you have multiples, you have like 2 or 3 kids at one time. It's crazy. All right, so if I ask you guys right now, let's talk about end behaviors. I know it doesn't ask for that right now, but let's talk about end behaviors of this lovely graph that we have here. You can tell me the end behavior just by looking. First thing I have to stress to you guys is if it is not in standard form, meaning if the biggest exponent is not first, you need to rewrite it so it is. That'll be the first thing that they do and try and trick you. They'll write like 2x squared minus x cubed. So you think it's even because it's 2x squared, but you got to put the highest exponent first. So what is the highest exponent you see?
X cubed.
X cubed. What kind of a number is that? Even or odd? Odd. So that means my arrows are going to go in opposite directions, yes? Is it positive or is it negative? So think about what a positive line or a positive cubic graph looks like. Describe the ends of that line. We always read left to right. What's going on the left-hand side? It's falling. So it's falling left. And doing what? Rising. Right. You can say falls and rise. Just make sure you have the direction and what it's doing correct. Now, if you're asked to tell the zeros, what does that mean? What do they want me to do? Algebra 2. How do you find the zeros of this function? What did I just tell you zeros mean? Solutions, roots, x-intercepts. What do we have to do to find zeros? Okay, we gotta have to factor it, right? How many terms do I have? 4. First thing we look for is GCF. Is there a GCF? Is there a number or a letter that all 4 of these have in common? What's up?
Is this where you just do split the middle?
Mm-hmm. So now I'm going to group the first 2. And I'm going to group the second 2. What do you guys notice I did with that negative sign in front of the 4? I kept it in my parentheses. If there's keep that sign there. So I look at my first parenthesis, x cubed plus 2x squared. What do they have in common?
You have 2x. Or, x.
X squared. Good. So if I divide out x squared, I'm left with x plus 2. Good. Now in the second parenthesis, what can I divide out? -4. Let's take out that -4. So I'm left with x plus 2. The reason we keep that negative in there is because now, do you notice when I took out that -4, both of the parentheses that are left over are the same. So that's my new GCF. I'm going to bring that out in front. I write it 1 time. And then what happens with all the good stuff that's left over? It gets its own parenthesis. Now I always check. Did I simplify? Is there anything else that I can factor? X plus 2? Is there anything I can make smaller? No. What about x squared minus 4?
You can have it as x minus 2.
Perfect. X minus 2 and? Good. Difference of perfect squares. Yep. So now, again, we haven't found the zeros yet, but we're real close. What's the next step? What do I have to do with all of my parentheses? Set them equal to 0. So this is really x equals -2. This is x equals +2. And this is x equals -2. So you guys found my zeros. How many zeros do I have? How many x-intercepts do I have? 3. Look at your equation. What was the highest exponent? 3. Whatever the highest exponent is, that's how many answers you should have. Now some of you are going to say, oh, do I have to write x equals -2 twice? You don't have to, but there's something you're going to have to state, and we'll talk about that in a second. How many times do you see x equals -2? Twice. That's called multiplicity. You guys would tell me, does this equation have multiplicity? Does it have an intercept that occurs more than once? Yes. So that's the multiplicity. Talk about that right here. If the multiplicity occurs an even amount of times, the graph, when you graph it, is going to touch that point and turn. We say bounces or touches and turns. I'll explain it a little more in a minute. Touch and turn. If it's an odd amount, it's going to go through that point, through the axis. So if you came out like we just had and you got x equals -2, x equals -2, and x equals 2. When I graph this, my graph is going to do what at -2? Is it going to go through that point, or is it going to touch it and turn the other direction? How many times do you see -2? Twice. Is 2 an even number or an odd number?
Even.
Even. So it's going to bounce. It's going to touch and turn here. I'll show you what I mean. What's it going to do at +2? Go through it. Good. Cross it. Good. So if you had x equals 3, x equals 3, x equals 3, and x equals -3. Well, how many times do you see x equals 3? 3 times, okay? There's multiplicity there. If it's an odd amount of times, what does it do at that point? Austin, you are correct. Since it's an odd number of times you see it, it's going to go through. How many times do you see -3? Once. Is that an odd number or an even number? So it's going to go through. So you would say here, on the left-hand example, we'll say this is example 1. Do you have multiplicity in example 1? Yes. How many times? Twice. Multiplicity means the same answer more than once. In example 2 over here, do you have multiplicity? Yes. Where? At what number? X equals 3. And how many times do you see it? 3 times. Good. Now, this helps you in order to graph. On the quiz, I'm not going to ask you how many turning points there are. But in order to know how to sketch your graph, You need to know how many bumps there are. That's the turning points. To figure out how many bumps there are, you take n minus 1. N is the highest degree. Highest degree, the biggest exponent. And you say n minus 1, and that gives you how many bumps. So look at this example. This is x to the 5th power, right? Everybody see that? X to the 5th. All right, so if I asked you, well, how many turning points are there? How many bumps are in this graph? You would say 5 minus 1, which is 4. So count them. 1, 2, 3, 4. You see that? Yes? Okay. Okay, let's talk about all this. There's questions on here, but these are the questions that I'm gonna ask you on your quiz. First thing I'm gonna say is describe or determine the end behavior. I know we just had this problem. I don't know why the example is the same, but let's just go with it. How do I determine end behavior? What do I look at? The highest exponent. Good. Okay, so I look at the highest exponent. What is it? 3. Is that an odd number or an even number? So remember, odd goes with what other word? Opposite. Is it positive or negative? So think about the way a positive line would go, or a positive cubic graph. What's going on the left-hand side? What's going on the right-hand side? Good. Falls left, rises right. Good. Does that make sense? You guys okay with that? Okay, how many turning points is my graph going to have if I graph this? How'd you get that, Austin? Very good. The highest exponent, which is 3. So 3 minus 1 is 2. Good. That's how many bumps. What if I asked you guys, because you're going to need to graph the y-intercept. Well, what's the y-intercept here? How'd you get that? Because it's right there. You plug in 0 for x's. Good. Good, good, good. And now we already figured out what all the x values were, didn't we, in the last problem? Didn't we do it?
2 negative 2s and 1.
Right, 2 negative 2s. So I'm going to say x equals negative 2. X equals 2. What did you tell me was happening at negative 2? Since I had it more than once.
Go through.
Okay, if there's multiplicity.
It's turning.
2 times. Good. Hang on one second. At negative 2. And then what is it doing there? Is it going to go through the graph, or is it just going to touch it and turn back the other way? Touch and turn. Very good, guys. That's important that you guys see that. That's usually the hardest thing to see. So it's going to touch and turn. What's up? Yeah, sure. And then here it's going to go what? Through. So look, you're going to have to sketch a graph. So let's sketch a graph here. And again, I am not asking for perfection, believe me. I know everything that I draw is always just wonderful, and you guys totally understand everything I do. So let's pretend that everything is perfect here. Do you guys see why I have negative 8 on my graph?
Yeah.
Okay, why? Why did I put negative 8 there?
The y-intercept.
That's the y-intercept. You have to graph the y-intercept and your x-intercepts. So I'm going to have a point at negative 2. You don't have to put 2. Just put 1 point at 2, negative 2, and I have 1 at negative 8. Now you guys are like, oh, what is my graph supposed to look like? How do I figure this out? Well, give yourself some little guidelines. What did you tell me the end behavior was? Falls on the left, so you agree that there's going to be like a little arrow down there?
Mm-hmm.
And then it does what on the right?
Right.
It rises. So in your mind, don't draw anything yet. So in your mind, coming down here from the left-hand side over here, all right, I'm going to start my graph, and I'm going to go up to negative 2. What am I going to do at negative 2?
Turn.
I'm going to turn. Why am I going to turn? You're right.
Because it's a turning point.
So that's our turning point because we have multiplicity there. So I'm going to touch and turn there, and then I'm going to come back down at 8. I'm going to hit my y-intercept, then I'm going to go back up to 2. What do I do at 2? Do I continue going, or do I bounce again?
Go through.
You continue going through. Perfect. So in your mind, guys, before, this is the part that's going to give you the most trouble. We'll practice it more tomorrow. But this is the part that generally you guys get hung up on because you get confused on what do I mean by if you have multiplicity an even number of times, 2, 4, 6, 8, 10, you're going to bounce, touch and turn at that point. If you have multiplicity or you just have the root 1 time, so if you see it once or 3 times or 5 times, you're going to go through that point. But how many times did you tell me I was going to have turning points? How many bumps were going to be in my graph?
1, 2.
2. Do I have 1 there and 1 there?
Yes.
Good. That's going to be the hardest part. The last question on your quiz, I'm going to give you something like this that you're going to have to factor. And I'm going to say, tell me the end behaviors. Tell me the zeros. If there's multiplicity, state it. What happens at each point? Does it go through or touch and turn? And then the last part is to be to graph it. So we're going to get a handle on that. Yes, sir?
Whenever you go.
Good question. All right. This is if you're using...
our calculator?
Not today. Later on. We're going to get the concepts down and then we'll do. But this is how to do it in the calculator. We'll come back to that. Again, calculator. All right. Let's do 2 examples and then we're done. You're going to tell me everything. Tell me everything. First thing I want you to tell me is my end behavior. What's going on at the end? So end behavior. Well, what's the highest exponent you see? 4. So I see 4, and that's even. When I think of even, what direction do I think? Same or opposite? Same. We like these. Is this a positive x to the 4th or negative? So they're both going which direction? Up. So you would tell me it's rising on the right and doing what on the left? Yeah, good. Doing the same thing. Now, if I asked you how many turning points there are, how'd you get that? Good. 4 minus 1. So there's 3 bumps. Now I need to know what my zeros are. How do I figure out what zeros are? You're going to factor. Good. So I have x to the 4th minus 4x squared equals 0. What's the first thing we always look for when we're factoring? Greatest common factor. What can I take out of both? X squared. And I'm left with?
X minus 4.
X squared minus 4, yes? Okay, so then I have x squared. What does this break down into? X plus 2. Great. X minus 2. And then how do I figure out algebraically what those x values actually are? You set every little piece equal to 0. Now, how many answers should I have to my x's? How come? Right, what's the biggest exponent you see? 4. So if it's raised to the 4th power, then I should have 4 zeros. So if I'm going to solve this, I'm going to take the square root of both sides. Guys, when I take the square root, what goes in front? Plus or minus. Is there such a thing as plus or minus 0? No, but I'm going to leave that there because that means I have 0 how many times? Twice. So what do I have here? What do I say if I have something twice? Good. What does that also tell you about your graph? It's going to touch and turn. Yep. What's my x value here? Negative 2. What's my x value here? Positive 2. Good. What's it going to do at those 2 points? Go through? But this will help you now when you graph to visualize what this looks like. So I'm going to go over here. All right, so I have 2, negative 2. I have something at 0. What's my y-intercept? I got to make sure I graph that too. 0, good. So now we're going to make our graph. Let's think. What did you tell me the end behavior was? Rising right and rising left. So do you agree with me that I have arrows like that, going in both directions, up? Okay, so think for a second. In your mind, go from the left-hand side. What are you going to do at negative 2? Draw from that arrow. You're going to go where? Down. What do you do at negative 2? Go through it. Then you come back up and you do what at 0? Touch and turn. Then you go back and then you go back up and you do what through 2? Go through it. So it should be what kind of a shape? Kind of like a W. Now some of you are going to say, oh, how far down do I go? Don't worry about that. As long as you hit the X and the Y intercepts, I'm okay. So if you come down and you go like this, just make sure you go through 2, you bounce at 0, and you go, whoops. Sorry about that. Through 2, bounce at 0, and then go back through 2 again. Some of you are going to make your W go real low. That's fine. I don't care. What I need to know, I need to see that you guys understand where the x-intercepts are, where the y-intercept is, and what the graph does at those points. Does it touch and turn? Does it go through? That sort of thing. And we'll practice more of the graphing tomorrow.
McDonald's.
Except not. All right, let's do the last one. Tell me everything. End behavior. If you can't just look at it and just tell me, then go through how I showed you. Circle the biggest exponent. What is that number?
Odd.
It's odd. When I think odd, I think what?
Opposite.
Opposite. Great. Is that positive or negative x cubed? So it's going to go something like this. So tell me, what's going on the left-hand side? What's going on the right-hand side?
Falling left.
Falling left. Good, Melissa.
Rising.
Rising right. Good. Very good. How many turning points am I going to have?
2.
Good. Now I have to find my zeros. I got to find my x and y intercepts. Let's find. You guys can tell me the y-intercept. That's easy.
0.
Yep. Okay. So now let's factor. X cubed minus 9x squared equals 0. First thing I look for is greatest common factor. So I have x what? X squared. Good. Then I'm left with x minus 9 equals 0. Now what? Okay. How many intercepts do I have at 0? 2, right? There is no plus or minus 0, but if you put that plus or minus, then you remind yourself, ooh, I have what at 0? What do I call that when I have the same thing twice? Multiplicity. Good. Very good, guys. So at 0, what's my graph going to do? Touch and turn. It's going to bounce. You can call it either thing. And then where's my other x? At x equals what? 9. So let's graph. One, 2, 3, 4, 5, 6, 7, 8. Yay, good. Okay, so I have 0 and 9, right? So refresh my memory. What does our end behavior look like? Rising on the right. So I got an arrow over there. And what's it doing on the left? Falling. So in your mind, guys, think about it. At 0 and at 9, I have things going on. What is happening at 0? What's my graph going to do?
It's the, yeah. It bounces.
It bounces. It touches and turns. So it's going to go up to 0 and bounce and then go down and then come back up and do what at 9?
Go through.
Go through. So it's like this. Again, I don't care how far down you go, anything like that. That's not my concern. My concern is that you understand what's going on at each specific point. So right now, I gave you guys some problems to work on. I did not have you graph any of them. We'll do some graphing tomorrow. I just want you to work on telling me end behaviors, telling me turning points, and finding the zeros. I did a lot of factoring problems. I did a lot of factoring work, which is important. If I think 1 or 2 of them, you have something that factors. Let's work through some factoring problems here. What about if I had... And I said factor this. First thing you look for. Okay, what can I take out of both? So I'm left... Oh, wait. Make this x squared. I mean, x the first. So I can take out what? 3x. So I'm left with x squared plus 9. Agreed? Yes? Yeah. Okay. Guys, is that the difference of perfect squares?
Yeah.
No. Difference means it has what sign in the middle?
Minus.
A minus.
Does
So-
that have to be 2 next to the 27?
Yep.
Okay.
Yeah, I just made this problem up. So if I say 3x equals 0, and then over here, I have x squared minus 9 equals 0. Well, solve this. Divide both sides by 3, and you get what?
0.
Okay, x equals 0. That's fine. And then what do I do here?
I.
You were right. You're right.
Oh, okay, subtract.
Subtract 9. So x squared equals negative 9. All right, now what?
Square roots.
Take the square root.
And it's 3.
3 what?
Plus minus 3.
Plus or minus 3 what? 3
I.
what?
I.
Because it's imaginary.
I knew
Guys,
that.
how many real roots, solutions, zeros, x-intercepts does something like this have?
3.
How many real ones?
Oh,
Yeah.
Just one. What are the other two?
imaginary.
Imaginary, okay? On your homework, when you factor, you are going to get one or two that might come out imaginary. I'm not asking you to graph anything. You won't on your quiz because I want you to graph, and we can only graph real numbers on our coordinate plane. But if you come out with a square root of a negative, remember that is an imaginary solution. That means it does not cross the x-axis there. So this graph, whatever it is, will only cross at one point at x equals 0. So just don't get tripped up by that. Sound good?